get back from break, clean binder for me, and make sure you have numworks downloaded somewhere. All right, that's not optional. I'm requiring that. That's not optional. All right, because I'm getting after it when we get back from break, so everybody can pass this test. All right, before we worry about passing that test, let's pass the stats test on Friday. It's not that much. It's only 11 questions, not many points at all. So I just want to hit up a couple key points that'll be on there. Normal distribution. That's when you can go to your calculator. It'll come out and say these are normally distributed. If I go to my calculator, remember there's only two places you need to go on your other than calculation. Two places you should be on the test, and that is statistics. That gets you mean, median, mode, standard deviation, all those interquartile range, and then you should be living at distributions. Right? You hit distributions. We only have one spot. That's normal. You type in the mean and the standard deviation, which will always be given to you. And then you have to figure out what type of curve you need. Do you need less than, in between, or greater than? And then you type that number in. I can't stress this enough. Your calculator, I think every time you hear normal distribution, you just go right to the calc. Their normal distribution, the only thing your calculator is going to give you is the percent as a decimal. That's it. Okay, so if you're asked that, sure, go to the calculator. All right, but if it's another type of question where you're given the percent like 68, 95, the calculator's not going to help you. Calculator only gives you the percent. All right, so normal distribution is heavy on that test. How about these three? Survey, observational, controlled. So survey, I'm going to pull in every third person who goes by my door and record their shoe size. That's a survey. Observational, I want to see if there's any relationship between your high school GPA and college graduating from college. I can't separate you into two groups, can't give you a survey, so what I'm going to do is I'm going to find all the GPAs and see who's still in college and who's graduated. That's observational, something I can't test. And then controlled, we could do a bunch of different things, right? I have a treatment for weight loss, a pill for weight loss. So I spread you guys into two different groups, give one the weight loss pill and one the placebo, and compare the results. So I'm going to ask a question or two on those tomorrow. All right, formulas you need for tomorrow. Margin of error. How do you find the margin of error?
2 times the standard deviation.
Plus or minus, that's got to be in your answer if I ask for margin of error. Plus or minus 2 times standard deviation. That's it. Don't confuse that with if I ask for the confidence interval, which is now I take the mean and add and subtract the margin of error. So if I ask for margin of error on the test, I just want this. I don't want a confidence interval. All right, I'll ask for the confidence interval. This was back on day one, population versus sample. We all good there? Population is everybody, right? Sample is just the smaller piece. We all good? Because I'm going to have a scenario for you, and you guys got to pull the population out and pull the sample out. Yep.
Can you just quickly do a scenario?
Sure. There's probably something in your notes, I'm sure, or in your packet, as far as review goes. Yep, number 19. And this is exactly the type I'm going to ask on the test. So what's my population in that problem? All edge SUVs, right? All edge SUVs versus the sample I'm taking out, which is only 100 edge SUVs, all right? So there's the sample versus the population. And then what we went over yesterday, again, I appreciate all your patience and cooperation. I'll give you a difference in the means. You calculate the confidence interval. If it falls outside, it's significant. If it falls inside, it's not significant. All right, because if it falls inside, it's by random chance. If it falls outside, it is significant. I think I put 2 of those on there because they're always asked on the Regents exam. All right, anything for you? Because here's the deal today. I'm going to go rapid fire. I'm going to call in a number. Whether you know how to do the problem or not, I don't care. All right, I'll help you through it. I selected a couple random ones here from your review packet. I'll work with that person on it. If anybody wants to chime in with anything else, that's fine. Once I get through my set of questions, you can do your thing on your own. But I can't let you just go on your own and say good luck tomorrow or Friday. Anything here on the topics? All right, let's do this. We're going to start with number 1 on the packet, number 1 in the review. All these answers, if you're doing a review on your own, all these answers are up on Classroom. All right, let's do this. First up here today, Grant, you ready?
Yeah.
All right. So you read through it. There is one little catch here we got to talk about before I do it. She waited 6 minutes at the drive-through. Yep. The mean is usually 226 seconds, and the standard deviation, given 95% confidence, was her wait time unusual. So, Grant, I'm going to have to find the confidence interval first. But before you do that, actually, we can find it right now. I'll talk about the catch before we answer the question. So how do you find that confidence interval, Grant?
I do it the longer way. I do the MOE first and then the confidence interval.
Okay, all right, what's the mean?
The mean was 226.
Yep, 226. I'm going to do plus or minus. How do you find the margin of error here?
226. And then the final margin of error is plus or minus 2 times 38.
38 in this case. Good. Yep. So there's my confidence interval. Let's now calculate the confidence interval. You have it already there, Grant?
Yeah.
All right, go ahead. I got it.
150 to 302.
Yep, 150 to 302. Now here's the catch. I got 6 minutes, right? But what's your confidence interval in? Seconds. That's a problem. I got to convert. All right, so 6 minutes. How many seconds are we looking at?
And what?
6 minutes. How many seconds? That's what I need. Because I can't test out 6.
360?
360 seconds, right? All right, Grant, where's 360 fall?
360 falls outside.
So that's unusual. All right, because about 95% of the people waited 150 to 302 seconds. All right, but good old Elizabeth here waited 360. So is our wait time unusual? Yes. And then our standard response, because it falls outside the 95% confidence interval. All right, all good. All right, I'm going on to question 2. Thanks, Grant. Here we go. Drew, ready? Okay, question 2. Male heights students are approximately normally distributed. Now, here's exactly what I was just talking about. You guys see those words, I got to automatically pick up my calculator and go to distributions. Not on this one. I don't need the percent here. I'm told the percent is 95% of the heights are between 62 and 78. So, Drew, 95. What's that? Within 1 or 2 standard deviations? 2. Within 2 standard deviations. Right? So if I have 0, which is my mean, I have 1, I have 2, up here is 78, and down at -2 is 62. Just because you see normally distributed doesn't mean your calculator will only give you percent, but I know the percent. So here's what I'm looking for your help with, Drew. I know this is -2 to 2, and I'm looking for this bad boy right here. What's the score here? You're given the standard deviation is 4. How can you use that to move me closer or further away here, whether you start at 62 or 78?
You just add.
So you're going to start at 62.
Yeah.
Yep, and add 4. So if I add 4, I end up with 68, but that's 1 below. I'm looking for the mean, right? Yep. So add 4 again, and we're looking at 70. What did I miss here? 66. Sorry. Yep. 1 job. 66, and then add it again. It should be at 70. There we go. So the mean is 70. Okay, so watch out. Hey, just because I say normally distributed, if you know and again, is this percent going to be any different than 95 or 68? Nope. All right, not going to do that. It's only going to be 68 or 95. Yes, Harper.
Can you just show all that?
Some type of work on how you got to 70. Yeah, it doesn't need to be this exact work. You can certainly say 62 plus 4 is your work. That's fine. It doesn't have to be a curve like that. Okay, thanks, Drew. Where am I going now? I pick number 5. Number 5. I'll let you read through that. And for this one, remember there's only 3 methods, right? I can use 3 methods. I got my survey, I got my controlled experiment, and I got my observational. Okay, so which one am I using here when I take every 3rd student entering the school to ask them whether they are left-handed or right-handed? Which one am I using here? What do you think? Here we go. 9, Harper.
Observational.
Why do you say that?
Just to guess.
Okay, all I'm doing is asking them, are they right-handed or left-handed?
Yeah, but
Right? That's all I'm at. It's like if I give them a piece of paper and say circle left or right. It's all that is giving you a survey. Okay? All right, I don't know. You got to help me out here. Observational is either A, watching and making observations from, or B, going and collecting data from data that's already existed. All right, like I want to know how many, on average, how many, is there any relationship with the high school GPAs versus college graduation? So what I'm going to do is look up everyone's GPA and then look up if they've graduated college or not and try to make some kind of relationship. That's observational. Me gathering all the facts and making a decision on it. Okay? Anybody else survey? All right, let's go to 6. One person's going to do 6A, one person will do 6B. They tell me the mean is 20, and I got a standard deviation of 2 ounces. So you guys help me out. How many boxes? If W is the weight, which range of weights include all the weights of cereal boxes that are within 2 standard deviations? Within 2. What are the weights that are within 2? Here we go, Kate. What's my mean, Kate?
20.
What is it? 20. All right. Can you help me get out to 2 and down to -2? What's my standard deviation?
2.
2. All right. So at 1 above, it'll be what? What will be the weight at 1 above? What do I have to do with the 20 and the 2 to get to 1 above? Okay, so it'll be at 22, but I'm looking within 2 standard deviations, so I got to do it again. And what do you got? Okay, so 24 on this end. Now I got to go down to -2, 2 below. 18, and then 16. So those weights are going to be anywhere between 16 and 24. Okay. And then I wanted to do part B with you. Just watch out. Watch out. All right, I even got fooled by this one. All right. The number of boxes now. Number of boxes. Which one could be that are more than 2 standard deviations above the mean? More than 2. Here we go. Richie, what number did Kate just find that was 2 above the mean?
24.
Okay, 24. So I automatically looked at this and said, oh, answer's got to be 36. But they're asking for the number of boxes. Number of boxes. So I got to go back to my chart here, and there's only one weight that they put that was above 24, which is 25. And Richie, if you can read that graph, how many are at 25? About 2. Yep. So be careful there. That one is the number of boxes, not the weight. Number 9. Oh, going to ask a ton of this. Ton. Be ready. There's going to be a ton of these. And I put a ton of these on here because that's what the Regents is going to ask. All right, who's up? Here we go. Question 9. 1-4. Isabel, ready? Ready? You got this. Normally distributed, so I might be going to my calculator. We'll hold off there for a second. I got the mean, got the standard deviation. There's 820 calf births. Beautiful. How many are expected to be between 270 and 290? Right, between 270 or 290. First thing I need is what percent is between 270 and 290. So now I can go to my calculator. So can you direct me where to go on the calculator? It's my first day doing this. I'll go back to the home screen. Where do I go? There's the keywords right in the problem. Distribution, yep. All right, let me go back. It's asking you to put in the mean. So what are we looking at? 284, yep. Let me just get to this problem. 284. And what's the standard deviation? 12, got it. All right, got everything I need. Enter. Now, which one am I looking for here? The less than, the in between, or the greater than? In between, you got it. Yep, in between. So I'll select that one on my calculator. Now I got to tell it in between what? 270. And what was the other one? 290. Okay, so I hit enter. What is this giving me though? This is not giving me the number of calf births, obviously. This is giving me what? The percent, right? This is giving me the percent. And now how can I use, or the percent as a decimal. So how can I use that answer with the 820 calf births to find out how many are between now? What can I do with my number I just found on my calculator and that 820? So we're saying about 57% of those 820. It's 57%. What I'm finding is 57% of the 820. So I don't want to divide the two. I want to multiply it, but multiply it as a decimal. All right, so hey, we did this earlier. I did it today again. I don't know if I can do it on mine up on the board, but I know you guys can. Hey, take a look, quick peek. Shift, copy, go over back to calculation, paste. It'll paste it there for you. Multiply by 820. And I did not put any rounding directions, did I? Did I? So, well, let me talk about rounding here. I'm going to say 467. Okay, 467. So again, if you want to show work, show me this right here. Okay, you can show me this right here. Also, what do we talk about when you do these normal distributions? Show me the curve, all right, with the number line on the bottom, what's shaded in. Okay, then you can take that number right here, 0.56979. I'm multiplying it by 820, and that gives me about, what was it, 467. Questions? There's going to be a ton of those. I don't really care about the percent. Why? Because your calculator does it for you. It's going to be how many at the end. So you have to use the percent with the total to find out how many. All right, there's going to be a ton of questions on those. All right, thanks, Isabel. You good? Sure. All right, one more here with somebody else. What's that? Number, we can get to it in a sec. Yep, just let me get through this one here. Here we go. We already went. We already heard from Drew. I don't want to hear from him again. Somebody new here. There we go. Gabby, let's roll. Standard deviation. Oh, it's normally distributed. What percent of batteries last at least 70 hours? Number 14. Sorry, guys. Number 14. Where are we going here?
The calculator.
Yep. All right. Tell me where to go. Tell me what to do here. Where do I go? I'm going to go start from the home screen.
Go home and then to distributions.
There you go. Yep.
And then
Normal. Yep. And then what's my mean here?
the mean is 60.
Is it 60? I don't know.
Average.
60 hours, yep. And a standard deviation of
5.
5, all right. 5.
And then
Enter. Yep, which one do I want here?
you want the lifespan. What percent of batteries has last at least 70 hours?
Oh, how about that word in there, kids? At least 70. What's that mean to you? At least, I have at least $70 in my pocket.
It's over 70.
There you go, 70 or greater. So I want this last one.
And then plug in 70 for the 0.
Yep. And we'll go nearest percent here. Hey, be careful. This is what a lot of you guys got confused on the quiz. That's a decimal. What do I need to do to convert it into a percent if I ask for a percent tomorrow? Multiply it by 100 or just move that decimal over 2 spots. Okay, over 2 spots. So let's say here I go nearest tenth of a percent tomorrow. Nearest tenth of a percent. Read the rounding directions on Friday. Nearest tenth of a percent. 22?
2.3.
Whoa. Move it over. Ready? 1, 2. 2 point, that's 7 rounds it to 3. So 2.3%.
And then do we have to draw the graph?
Yeah, I'm not going to, but yes, that's what I would need for work tomorrow. I mean, Friday, wherever you're taking it, I need this graph with this little piece shaded in. All right. Okay, how many of the 1,500 batteries are within 1 standard deviation? A couple different ways we could do this. Here we go. Within 1 standard deviation, how many of those 1,500? All right, let's do this. You ready, Marty?
Sure.
All right, well, before you tell me how many of the 1,500, I need to know what percent of the 1,500. So there's a couple ways we could get to it.
Well,
Go ahead.
it's within 1, right?
Yeah, so
68.
there you go. Yep, since it's normally distributed. Oh, you want within 1? 68, 68.2%. There you go. Yep. All right, so I know it's 68% of the 1,500, Mari. So what can I do with the 2?
Multiple.
Okay, not 68, but what? Yep, which would be what?
0.06 or no 0.68.
0.68. Yep. There you go. Was anybody thinking about actually finding, like taking 60 and adding 5, subtracting 5, and then putting that in your calculator? Still going to give you 68.2%. All right. And what am I looking at here for the number of batteries? About 1,023? Or what do you guys have? I did 0.682. 1,020? Okay. Okay, anything you want to ask? All right, please keep focused on these problems. Let's go. Keep focused. Get your Chromebook out so you can see the answer key. Let's not take 20-minute bathroom breaks here. Let's get focused on it.